So our topic for today is the Kirchoff's voltage law, or the KVL. So in Kirchoff's voltage law, if you have a closed circuit, the voltages of the circuit must add up to zero. Some voltages are positive and some are negative. So you need to determine which one are positive and which one will be negative. So based on this resistor, okay, so let's say this is 10 volts and this is 20 volts. The current flows from high potential to low potential in a resistor. So it flows from positive to negative. So the resistor consumes energy. If the current flows from high electropotential to low electropotential, the energy of the charges that is flowing in that circuit is actually being reduced. So the energy is being transferred from the charges to the resistor. So therefore, as the resistor decreases, the energy of the charges we're gonna assign a negative voltage because it reduces the energy per unit charge. While in a battery, so this is a battery, it is different. Current can flow from low potential to high potential. That's it. So this could be 0 volts and this could be 20 volts. Okay, so whenever the current is flowing from low potential to high potential, so this is negative to positive, that means that the energy of the charges is increasing. So this is gonna create a positive voltage because the battery is transferring energy to the charges. And so it increases the voltage of the charges, but the resistor will reduce or decrease the voltage of the charges. Now let's see if you understand. So let's say we have a resistor and its current is flowing in that direction. So will we assign a positive voltage or a negative voltage to the resistor? So keep this in mind that the resistor always creates a voltage drop. It always consumes energy from the charges, so always assign a negative voltage for a resistor. Now, what if we had a battery that's listed in this way? So this is positive and negative. But the current direction is the same. I mean reverse. So this battery, is it increasing the energy or is it decreasing the energy of the charges? And compare it into this situation. So this is positive and negative. Okay. So compare the two. So which one which one should we assign a positive voltage and which one is negative voltage? Anytime the current flows from high potential to low potential, from high potential to low potential. Okay. So if that is the flow of the current, the energy of the charges is being reduced. So this is gonna be a negative voltage. While if it flows in the opposite direction, I mean it's like this, the voltage or the energy of the charges is increasing. So this is positive voltage. So let's go back to this diagram. The current flows from high potential to low potential. So from positive to negative. So this battery reduces the energy of the charges. So it has negative voltage. Okay. So while in this diagram, the current flows from low potential to high potential. That means that this battery increases the energy of the charge. So this is positive voltage or volts. Okay. Now let's work on some practice problems. Let's say we have a battery here. That okay, that's it. Assume that it is connected perfectly. And then it is connected with a 3 resistor. Okay. So this is 12 volts. This could be 8 ohms and 10 ohms. And this is 12 ohms. So let's say this is R1, R2, and R3. Okay. So write an expression that highlights the Kirchoff's voltage law. Show that the sum of the voltages around the circuit must be 0. So now, the current is going to leave the positive terminal. So it is going to flow in this direction. That's it. So as it flows through R1, the voltage will decrease. But the battery in which the current flows is from low potential to high potential. So the battery supplies energy to the circuit. So we're gonna put positive VB for voltage battery, and then minus V1. That's the voltage drop for R. That's the voltage drop across R1. Minus V2, the voltage drop across R2. Minus V3, the voltage drop across R3. And as it says a while ago, the sum of all the voltages is 0. So this is equal to, this must be equal to 0. Okay. So since the voltage battery is 12, that is positive 12 minus V1. So V1, we know that V is equal to IR. So V1 is I times R1. So the current, because the current is the same in the circuit, as this circuit is a series circuit. So R1 is 8, so we can write 8 times I, because because of the I times R, minus V2. V2 is 10, so 10 times I minus V3. R3 is 12, so 12I equals 0. And then we can add these like terms. So bring down 12 minus, or negative 8 plus negative 10 plus negative 12 is negative 30. This is 30. I equals 0. And then we can transpose this into the other side. So it will become 12 equals 30I. And then divide both sides by 30. I is equal to 12 divided by 30, 0.4 amps. So now that we have the current of the circuit, let's calculate the potential at every point. Okay, so the electropotential of this point is 0 volts. So let's calculate the electropotential of these points. So let's say this is point A, point B, and point C. So notice that the potential difference of the battery is 12 volts. Since this is a positive sign, point A has to be higher than this point. So at point A, the voltage is where the potential is 12. So this point A is also 12 volts. Okay. So now, what is the potential of point B? So we need to calculate the voltage drop across R1. So we can use the V is equal to I R1. So since I is 0.4 amps and R1 is 8 ohms, that is 3.2. That means that the voltage is dropped by 3.2. So we need to subtract 12 volts minus 3.2. So 12 minus 3.2 is 8.8. So 8.8 is the potential for point B. Okay. Next, how about the potential of this point? So if we calculate the voltage drop across this point, V is equal to I R2. So I is 0.4 times 10. So that is 4 volts. Okay, and then subtract 8.8 minus 4, that is 4.8. So the potential of this point is 4.8. This is 4. Okay. Next, let's see if this is correct. If this point is 0 volts by computing the voltage drop across R3. So IR3. So 0.4 times 12, that is 4.8. And then 4.8 minus, or yeah, 4.8 minus 4.8 is 0. So 0 is this point. So we got the correct answer. That is how to calculate the potential difference of each point. But if that is not necessary, then just give the voltage drop. Okay, so what if the question is asking for voltage drop of the circuit? Okay, so just simply V1, or the voltage across R1, is IR1. So that is 0.4 times 8. So we will get 3.2. Okay, that is V1. How about V2? 0.4 times, or I times R2, that is 0.4 times 10, so that is 4. Then V3 is IR3, so that is 0.4 times 12, that is 4.8. Okay, so these are the voltage drop across the circuit.